And this is, so we have this function, this is depth versus clock time. And this goes back to graphing by transformations, okay? And that's kind of the big thing that I really want to see. Okay, so depth versus clock time. Quadratic formula says zeros are at negative of -5 plus or minus the square root of -5 squared minus 4 times 2 times 2 all divided by 2 times 2. Now that's identifying A, B, and C and putting into the quadratic formula, which everybody knows. Okay? And then you simplify that. It's 5 plus or minus the square root of 25 minus 16. Of course, that's 3. That's going to be convenient. Okay? Over 4. Okay? So what's your vertex?
5 plus or minus.
I'm sorry? Somebody said it. 5 over 4, right?
Yeah.
Okay, are we used to this? I know I've said it a dozen times in the last week and a half. Okay? So here's your vertex. Vertex of your parabolic graph. Okay? Now this is 5 plus or minus 3 over 4, because this simplifies to 9 inside here, and square root of 9 is 3, right? Yeah, everybody's going to get that. So what you're going to get is 5 plus 3 over 4, which is 2, right? Or 1/2. Okay? Everybody okay with simplifying 5 plus or minus 3 over 4? 5 plus 3 is 8, 8 over 4 is 2, right? 5 minus 3 is 2, 2 over 4 is 1/2. Okay? Vertex of your parabolic graph. Is on the axis of symmetry. And I said vertex, I really should have said axis of symmetry, is at x equals 5/4. Okay? What's this tell you? It tells you that your graph, such as it is, has zeros at 2 and 1/2, if we assume this is 1, right? And the axis of symmetry is at 5/4, which is 1 1/4, right? And then the only thing you got to figure out is how high or low you have to go on this axis of symmetry to get your vertex, right? How do you get that? And I said x equals 5/4. It's really t, isn't it? Because we're graphing y versus t, not y versus x. Okay? I don't think I have any other. We'll put t equals that. Okay? How do we get the coordinate on the vertex? Well, we know the x coordinate and the t coordinate. We just plug it in. Okay? And there's another x, t. So if t equals 5/4, y equals 2 times 5/4 squared minus 5 times 5/4 plus 2. In other words, I'm just plugging 5/4 into this, right? And I work that out. 5/4 squared is 25/16, so it's 25 over 32 which is a little less than 1, minus 25 over 4, which is over 6, plus 2. Okay? Put all that over common denominator of 32, if we want to. And we get what? Negative 175, and 64 is negative 114. 114 over 32. Don't take that to the bank or anything, that could be wrong. And that reduces down, but that's approximately equal to 3.96 to 14, 3.6. And it's negative.
I'll take a picture of it so you.
So we come down here to negative 3.6. We've got the vertex, and we've got our two zeros, right? So there's our parabola. Okay? What's its vertical shift from the y equals x squared graph?
Is that 2?
Well, the horizontal shift is 5/4, right? Vertical shift is about negative 3.6. And what's the vertical stretch? Well, I'll address this a little more in a video, but this is it's a transformation of your basic squaring function. Okay? Well, if you replace t with t minus h, you're going to get t minus h quantity squared. That's still going to give you just a t squared, right? And you multiply that by a, and you've got to get this. So a has to be 2. A has to be whatever's in front of t squared. So you could draw the basic squaring function, transform it by doubling all the y coordinates, right, with arrows, move it over 5/4 of a unit and down 3.6, and it should match this. Okay? Okay. Now, quickly,